Welcome friends, welcome you all in my channel Chemistry the Mystery of Molecules. I am Tanmay. So today we will discuss a problem appeared in the GATE exam 2018. It is I'll say it's a very easy problem, but for that you must have very precise knowledge about the reagent and reaction condition. Okay, and initially I will explain everything in details, and at the end of this video I'll explain how to solve this question within 1 minute, or more precisely if we say within 30 seconds, because this problem is easy. So let's start. First of all, we need to understand what reagents are given. First we have to see the molecules properly with a cool mind. This molecule, what functionality? One ester, one tertiary butyl ester, one double bond, and one methyl ester. Two esters are there. Another thing, CF3 acetic acid, carboxyl means trifluoroacetic acid, and second is BH3, more specifically one equivalent. You have to focus that part. So, what trifluoroacetic acid does, it selectively cleaves this Boc group into carboxylic acid. So the first part is done. It is selective reagent for the removal of Boc. Actually, this tertiary butyl group, this T-butyl group, it will remove this T-butyl group selectively. Why? Because protonation will happen both stage, but when protonation will happen, it will produce a tertiary butyl carbocation and carboxylate minus. Carboxylate minus will be produced both cases. Here, if this reaction happen, it will produce methyl plus carbocation. Here, tertiary butyl. We know that tertiary butyl is more stable. So, at this mild condition, means this trifluoroacetic acid mediated condition, this will deprotonate to produce this carboxylic acid. This is the reason why this methyl ester is not hydrolyzing in tertiary butyl, due to the stability of tertiary carbocation producing this tertiary butyl. Okay. So second, BH3 one equivalent. What does? Actually, when BH3 is reacted in presence of acid, it reacts acid first compared to ester. Okay. Why? Because both coordinate logically, but this will coordinate stronger because this carboxylic acid may remain in equilibrium with its corresponding carboxylate. And another thing, it produces H plus, and if we consider BH3, this BH is delta minus, so they react very fast to liberate hydrogen gas. And if it liberates hydrogen gas, what will happen? This BH2 will remain attached to this carboxylic group. And if this attachment is achieved, then reaction will happen this. So this is the reason of selectivity for attachment of BH2 with this. And more specifically, if we say this BH2 will prefer to attach with this, because when negative charge, it will undergo resonance and this oxygen will be more active. So this is BH2. Similarly, actually what happens, this binds with another BH2 also, but another BH2H, but you may be little confused that when reagent is less, how this happens. Actually, I'll give you the counting at the end, that how this is happening. But you accept, actually this is the mechanism, that's why I'm explaining. You may skip this part if you already know the mechanism. So here this boron is octet filled, here this has a formal charge, and this oxygen has a formal charge because coordination, and it will attach here. So in this way, what will be produced? These will produce, I will consider this double bond part as R. It will make the picture little simpler. Means what will produce here? O BH and OBH. This is R, means this part, the whole part, and here already one hydrogen attached, this oxygen, this BH2. Okay, what happens after that? After that, this can push and this can go out. So what it will produce? It will produce an activated carbonyl derivative attached with boron hydrogen, and this oxygen is formal charge. And here R means this part, complete. Okay, R, this is hydrogen. Right now, this center is very electron deficient, double bond O, and O oxygen has a formal charge over it. And you can consider this is as means carbonyl group, ketone or aldehyde more specifically, is attached to this boron. Then this hydrogen will come here, okay, and this bond will come here in this way, charge neutralization. So what will happen? So this boron with hydrogen and oxygen, HR. So another hydrogen came, so this. So to point out that in first stage this hydrogen came, hydrogen 1, this is hydrogen 1. In second stage this hydrogen came, hydrogen 2. Okay, so clear. So after this hydrolysis happened, what produce? RCH2OH. Okay, it's a primary alcohol, CH2OH. So this is the product. So okay, done. Now our question, we will stop here. Why? I will give you a details. Means I can I can discuss about other reduction. You can say that other group will reduce. Actually, will not. Why? I will explain. First, I want to give you a priority. First this part, second priority this part, and third is double bond. And here what is happening? This is converting into, this carboxyl is converting into OH. Okay, and how many hydrides have taken? 2. And another thing, initially it first produced as carboxylic acid. So this is R, this is R, carboxylic acid. So it consumes 1 hydrogen. So if we consider about this BH3, this, so 1 hydrogen, let's consider that as HA, it reacts with 1 hydrogen H, so 1 hydrogen gone, and this HR1, HR2 for reduction, this HR1, this is HR2, means 1 hydrogen molecule produced initially, that came with 1 hydrogen and 1 hydrogen, so 1 hydrogen count gone. Second, both 2 hydrogens are utilized for this. So in this way, since it is mentioned in the reaction that 1 equivalent, so all BH3 is gone. So further reduction or further hydrobolation will not occur. So this is actually trick. This. So what is our answer? Our answer is, first of all, this is reduction and no effect of this group and double bond. So reduction is happens, no reduction here, actually no reduction, so this is gone. No reduction here, this is gone. Reduction here and here. Now question, you can see, you can see here both reduction but not possible due to lack of BH3, that is 1 equivalent. So this is not. So the answer is D. Okay? Okay. So let's come to the tricks, how to solve this question in 1 minute. First of all, for that you need to have a precise knowledge about reagent. CF3 will hydrolyze BOC to form carboxylic acid. First. Second, a carboxylic acid there which contains a delta positive proton will first consume one equivalent of hydrogen from BH3. That calculation I have given just some time before. So around 2 hydrogen left, 2 hydride left. 2 hydride left, and 2 hydride will reduce this with alcohol. Why? Because O minus will be attached to BH2. So in short, if you want to write, this BH2, this O minus will reduce this into, OH. Okay, so rest of R. So here, this is the only product. And second, you need to have an idea that CF3 syrup is selectively this, not this. So all the reagents is consumed for this part, no reagent left for other, so other will be intact. So within 13 seconds you can solve this question. Okay? So I guess you have understood the problem. So if you like my teaching, please give a like and share this video among your friends such that many people could get benefited from my effort. And finally, I request you to subscribe my channel Chemistry the Mystery of Molecules, and please press the bell icon to get the notification of every single video I upload. So see you in my next video.